Hey there, CJ Math students. So we're going to go ahead and do notes 6.3. This is part 1. The top here section is just kind of a review section of what we've been doing. So here, again, we solve inequalities just like we solve equations. So we add 5 to both sides, and we get x is greater than 17. What does this mean? I have to put a 0, I have to put a 17. It means an open circle and pointed to the right, everything greater than 17. This next one, same thing. Here I just add 8 to both sides. I get x is less than 21. Again, 0 and a 21. This is an open circle, and everything to the left, or less than 21, gets shaded in. Now here, I asked you to be careful because you need to flip it, because the variable is on the right-hand side. So we can go ahead and solve this. We can say plus 5 plus 5. That's 20 greater than or equal to x, and then you just need to remember to flip it. X is less than or equal to 20. Notice how I flip the signs and I flip these two guys. So 0's here, 20's here. This time it's a closed circle and everything pointed to the left, okay, or everything less than or equal to 20. Here we've got writing two-step inequalities. All real numbers such that the sum of 3 times x and 13 is less than or equal to negative 7. That's the sum of 3 times x, or 3x, and 13 plus 13 is less than or equal to, 13, negative 7. Here we have 6 less than, remember that less than goes all the way over at the end. A number k times 4, 4k, 6 less than, greater than 13. It doesn't say greater than or equal to, so I know it's just greater than. I'm going to allow you to do these two guys right here. Alright, identifying solutions. Whenever it says is the number a solution, this is code for plug in that number. And basically, you're going to ask yourself the question, if I plug it in, does it make it a true statement? So basically, I'm going to take negative 5 and plug it in right there. So 2 parentheses negative 5 plus 1, is that greater than negative 3? Well, I get negative 10 plus 1, is that greater than negative 3? Negative 10 plus 1 is negative 9, and is negative 9 greater than negative 3? No, it is not a solution because negative 9 is further to the left on the number line, making it smaller. And I want to say negative 9 is actually less than negative 3, but that's not what we have there, so no is our answer there. The next one, 13 minus 7y is less than or equal to 6, and I want to plug in there. So 13 minus 7 parentheses 1 less than or equal to 6. Alright, 13 minus 7 is less than or equal to 6. 13 minus 7 is 6. So is 6 less than or equal to 6? And the answer is yes, because it is equal to 6. If I had anything less than 6, if I had like 5, then my answer would be no. Right? Sorry, no, if I had anything greater than 6, my fault. Like if I had 7, then my answer would be no. I'll do one more. Let's plug in this one this time. So 13 minus 7 parentheses negative 3 less than or equal to 6. Right? So 13... so plus negative here, and negative 7 times negative 3 is a positive 21, less than or equal to 6. So here I end up with 34. Is 34 less than or equal to 6? My answer is no, right? 34 is actually greater than 6, so there's no way that that could be, negative 3 could be a solution there. The key thing here was recognizing that this minus sign made this 7 a negative, so then when you did negative 7 times negative 3, you got a positive 21, all right? Cool. A couple of things for solving inequalities. When solving inequalities, first make sure the variable is on the left side. That's the first thing you need to make sure. If it is, solve it like a two-step equation. If it isn't, flip the sign and rewrite the inequality with the variable on the left. Okay, so the variable is all already on the left. You can like wipe your brow all good to go. If the variable's on the right-hand side, then we got to do some work. You got to flip the sign and rewrite it. So something like this. 10 less than or equal to 5 plus 2x, right? Here's an example where I have to flip this. I have to rewrite this as 2x plus 5. Notice I've taken this and moved it over here, and then I flip the sign as well, greater than or equal to 10. All right, this is an example of a rewrite flip, okay? Let's go to the back side really quick. So less than or greater than, get an open circle, something like this, because the number is not included in the solution. So remember, like if I said x greater than 5, I'd graph it like this with an open circle at 5 pointed to the right. And the first number I could pick that would actually make sense there would be like 5.0001, or the first whole number that would make sense would be 6, right? Because 5 is not greater than 5. That's why it has an open circle. Now less than or equal to or greater than or equal to, get a closed circle like this, because the number is included in the solution. All right, so again, x greater than or equal to 5, just the only difference here is that little line right there, right? And then there's 0, there's 5. It gets a closed circle because 5 is included. 5 is greater than or equal to 5. That makes it a true statement, so that's why it's included and gets a closed circle. All right? Most important thing to remember, if you multiply or divide by, write that in capital letters, by a negative. Not if your answer is negative, but if you multiply or divide by a negative, flip the inequality sign. All right, this is the end of part 1. There's a lot of information here. Make sure you understand this stuff.